this teaching idea video that looks at building a model that demonstrates how a resting potential is maintained. Right, some key things to remember is that make it nice and big. Right, the bigger the better, so that students can really see what's going on. As there's a protein or a proton pump, you want a rotating protein in the middle. One good way to do this is get a fidget spinner that you might well have confiscated, stick it to the bottom of your protein so it spins round by itself. Use lots of different tiddlywinks to represent the different ions that are moving through, and after you've gone and explained it, you can get students to go and physically annotate the model to help with their own understanding. They can then go back and explain the model to each other. Right, there's a short clip next that shows how this model can be used in practice.
Well, right, this is just a very quick video about how the resting potential is maintained within nerve cells. Right, the first thing to remember, you have your plasma membrane. The plasma membrane is impermeable to different ions because the ions can't move it due to the charged heads. You have a higher concentration of sodium ions on the outside in comparison to the inside. This means that outside, relatively, the membrane has a higher charge or a more positive charge. This means that at resting potential, our membrane has a charge or a resting potential of minus 70 millivolts. So, when there's some sort of influx, so some sort of stimulation, the first thing that happens are the sodium ion channels open up. As the sodium ion channels open up, the sodium ions from outside our membrane can move into the membrane by diffusion. This means that relatively the inside of the membrane is becoming less polar, so it becomes depolarized. When depolarization occurs, this is called an action potential. After an action potential though, we need to get back to this resting state. So this is achieved by, we start off, the potassium ion channels open up, which allow potassium ions to move out into the extracellular fluid. This starts to increase the amount of positive ions on the outside. And at the same time, the potassium sodium pump pumps out 7 sodium ions for every 2 sodium ions that are pumped in. So relatively, sodium ions are being actively transported back into the inside of the membrane. So we're restoring, sodium ions are being pumped out, potassium ions are being pumped back in. So we're restoring that concentration gradient, and therefore the resting potential goes back to minus 70 millivolts.
Hopefully this video has given you some ideas how to teach this particular concept. If you've liked this video, please subscribe, like the video. There's links below to follow me on Facebook, Twitter, and there's a link below to my shop on test where you can go and get a full copy of this lesson. Please feel free to leave any comments or questions below and I will get back to you as quickly as possible. Thanks for watching and happy teaching.